Continuing our discussion of the predictive relationship between variables, we're now in a position where we can move on to talk about quantitative variables. So in the last few lectures, we talked about kind of a heuristic strategy for judging whether categorical variables have a predictive relationship. And it turns out that we're going to have sort of a nice heuristic strategy for judging the extent to which quantitative variables have a predictive relationship as well. So to begin that discussion, we're going to talk a bit about the correlation coefficient. And we're going to go ahead and jump right into using correlation in R in order to examine the relationship between variables. And so the main thing you want to get out of this lecture is being able to think of the correlation coefficient as a measure of how closely or strongly two variables, quantitative variables that is, are related. So as we've said, the correlation coefficient is just a measure of how much two variables are going to move together. And hopefully that'll be a bit more evident as we examine some data here in R. But the command that you're really going to want to use is this core command. And I can show you that here in just a second. So let's go ahead and open up R, and let's load the PLYR library and examine the baseball data set. I think we've talked about this data set before, but this has just a ton of records of baseball data going back all the way to the late 19th century. And we've got some information on a ton of different players, and we can see what year an observation is from, how many at-bats they had, how many runs they had, how many hits, doubles, etc. So in order to examine the relationship between two variables that we think are probably going to be highly correlated, let's go ahead and examine the relationship between at-bats and hits. So examining the relationship between at-bats and hits. So here I'm going to go ahead and plot the data. Because both of these variables are quantitative, we can go ahead and use just this plot command. And then you'll notice if I just run this plot as it is here, we've actually got so much data, we're plotting over 21,000 observations, that we just kind of get a mass of points here. So one strategy that's nice sometimes in order to clean this up a little bit is this PCH specification. So if you just say PCH and then in single quotes put a dot here, that'll change the presentation of what you're plotting a bit to make things a little bit clearer. So the important thing to notice here is that these variables are actually highly correlated. So we can see that in general, as a player has more and more at-bats, they also have more and more hits, which seems totally like what we would expect knowing what we do about baseball. So if we want to get a little bit more formal with this, we can calculate the correlation coefficient between these two using the core command. And then again, I'm going to use the $ to specify or to refer to specific variables. Baseball, and then hits is denoted with this H. So when we calculate that correlation coefficient, this is extremely high at 0.98. The correlation coefficient varies between -1 and 1. So +1 means two variables are perfectly correlated, and -1 means two variables are perfectly inversely correlated. So the rough way to read this is that a unit increase in at-bats is closely tied to a unit increase in hits. So in order to show you what two variables that are probably not closely correlated look like, let's look at the relationship between what year an observation is from and the number of doubles a player got. So examining the relationship between year and doubles. So here I'm just going to go ahead and copy this command, and I'm going to change at bats to year, and the variable for doubles is actually x2b in this data set. So if I go ahead and plot these, you can see that the plot looks very different. So we just kind of have a more or less random scatter for each year in terms of the number of doubles that various players got. So to kind of return to our discussion of predictive relationships, a difference for this plot is knowing the year that a player was batting doesn't give you a very good sense at all of how many doubles they got. Whereas if we go back to our first plot, knowing the number of at-bats that a player got gives you a really good sense of how many hits they were likely to get. I mean, it's not perfect because there is still some variation within the number of at-bats, but we can see that the relationship is much closer than the kind of scatter that we get here. And so if we calculate the correlation coefficient between these variables, we're going to see something that's much closer to 0. So in fact, these variables are slightly negatively correlated. So that is, in more recent years, we actually see slightly fewer doubles. But the important thing is that this number is very close to 0 to give us kind of a heuristic sense that these variables are not very closely correlated at all. So again, the main point of this short video was to examine the correlation coefficient as a rough measure of the predictive relationship between quantitative variables. And in order to actually implement this in R, you're going to want to use the core command.